Okay, I'm on my field site here. Now what I'm doing with the whole idea with the field site is to get a representative sample. We're not doing a biological study where everything has to be random. So I want to show the transition between the bush and where the transformation happened, where we had land clearance, because that's my issue I need to deal with, and how erosion could possibly affect it. But it's really the land clearance that's my job. I'm going to do a 40-meter transect trying to get a representative sample. So I want to get some trees in it, the normal grass that's in it, and then some of the bare patch that's down here. On the ground here, I've got my equipment that I've brought with me. I have the Quadrat, which I just made from some sticks that I got from the planting section of Bunnings. It's just to hold up tomatoes, really. I just used some duct tape and put it together. It's 1 meter by 1 meter. That's pretty standard, but you don't have to do that. All you have to do is use the same Quadrat the entire time. The reason I like 1 meter by 1 meter is you can use a small Quadrat, like the little 10 centimeter by 10 centimeter I have with the white card. That can be then just multiplied by 100 to then do a small sample area within that to give you a bit of an estimate. I have a tape measure. I'm going to measure every 5 meters down my pink surveyor's tape, which I'm going to stretch out along the line. I have an inclinometer with my protractor and a string and a bit of a washer so I can get an angle when I'm looking up at canopy cover. I also have a hammer just in case I need to tie something down, but at the time I actually found a bunch of rocks. And the last piece is a paper towel tube, paper roll sort of thing, and I used a cross section of some 2 strings going across to make divided into quarters so I can estimate canopy cover. And you could also use that to estimate ground cover if you want to do as well, by just dividing it, going, well, I've got less than a quarter maybe, and you can sort of add it together. There's a number of ways of doing that, but that's what I'm using for my site. The mini Quadrat, the 10 by 10 centimeter cardboard I've got, as it says, you sort of count the number of plants per species. Now, you only really do this if you've got so many within the 1 meter Quadrat that you can't possibly count it. And what you do is you work out how many you've got in the 10 centimeters and then figure out how many an estimate percentage you've got in there and then multiply by that. So if you have figured you've got 80% and you've got 15 plants per 10 centimeters, then you would multiply that 15 by 80 to give you a number for the 1 meter Quadrat. It's only when you have so many you can't count it. Otherwise, just try to count how many plants of each type of species you've got, so you can do your biodiversity index. Okay, now I'm going to use surveyor's tape to mark my transect. So what I'm going to do is I'm going to tie it off to a tree as my start point. I'm going to try to get a couple other trees in here as well if I can. I'll probably run it just through here in the grass and out onto there. I'm going to do every 5 meters, so I've got my measuring tape so I can measure every 5 meters. I've got a hammer with me. I'm going to tie it to the other end and maybe use a few rocks to sort of pin it down, otherwise it'll blow around. And that way I can use my phone to then use my EpiCollect to collect data at each of the points. So we're going to set it up like that. Okay, so this is my field site. I've tied some surveyor's tape to the tree, and if you follow the path down, you'll see that I've actually got surveyor's tape 40 meters down the hill between my transition where the land cover is and where the land cover has finished. Okay, I'm at my first point. Now I've selected a tree. I am going to take a height of the tree, and then I'm going to do a Quadrat here. So I've just placed my Quadrat down on the ground. Mine's made of simple bamboo and taped together with duct tape. So I'm going to actually do a count of that. So the first thing I'm going to do is, because of the species are a little bit hard to count on the entire thing, I've identified my species. I have a broad grass here and a couple little plants, and that's about it. And I'm going to include my tree in the Quadrat, even though it's right next to it. Remember, this is just a representative example. So in my Quadrat, I want to estimate how much I've got here. So there's not a great deal of actual vegetation in here. So what I'm doing here is just using a representative example using the 10 by 10 centimeter square. This actual site, if you look at it, there's actually not that much vegetation there, because if you just go to the roots,
there's only so many plants there. I would have normally just counted up how many are there. You've got to be a little patient with it. You'll get the number of each type. I'm just trying to show an example of what you'd do if it had like nearly 100% coverage, or I would say greater than 70% coverage of a certain type of vegetation. Then you'd use that 10 by 10 centimeters square.
So I've got my phone here, I've got my EpiCollect ready to go. I'm going to add an entry for this point. I'm going to update location. I'm going to try it again to get the accuracy better. And it is definitely not being very accurate here. It's saying I'm with accuracy of 2,800 meters. That's somewhere close to 2 kilometers. And there we go, that's a little better. So I hit the next button, and now I'm going to put this as site ID 1. And then I'll go down to the next bit. The transect distance is 0 meters. The next field underneath, scale of human impact, I'm going to put 0 here. I've got percentage of ground cover. My estimate was 20%. The canopy cover, I'm going to use a sneaky tool that I've built out of a tube and got little crosshairs, and what I'm going to do is I'm basically going to stand in the transect and look straight up at the sky, and I'm going to make an estimate of how much of the quarters are covered by the canopy. And my canopy cover is going to be 60% because I'm right under a tree. So the last one I've got here in my first section of my EpiCollect is vegetation height. I'm actually going to take a height of the tree. I'll have to go back 10 meters and use my inclinometer. I'll show that in a few minutes, and then write that down in my field notebook so I can do a calculation on that. So I'm actually okay with that. I'm now going to go and look at the biodiversity. So my plant 1, which is my long grass species,
For putting in the plant biodiversity, that it depends on how many plants you have. Now I showed an example using the little 10 by centimeter by 10 centimeter. You'd have to multiply that by 100. That's again only if you really got about 70 or 80% coverage and you really can't count every single plant. For mine, there was no more. I sat down for that first quadrat here that I'm showing you, and I counted up a total of 80 little plants of those grass and about 10 or 15 of the others. There wasn't very many, and there was a third little plant that I found plus the tree. So it was 4 different species. I put it in there, species 1, species 2, species 3. I'm going to use that consistently down. I noted it in my notebook, and then what I would do is just count that down, add it in, and that will go in so I can then calculate my species biodiversity index.
Okay, I'm going to measure the height of the tree here. So you've got to do at least a minimum of 10 meters to make it work well. My long pace is a meter, so I'm going to step out 10 meters here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm using my inclinometer here. I'm going to aim through the little straw to the top of the highest branch I can see, and I'm going to let the string dangle down. I'm going to measure just make sure I get that right. And I'm going to measure how many degrees that's changed from the 90. So it's gone through to the 40, so I know it's gone 50 degrees. So in my field notebook, I'm going to say it's 10 meters length for the triangle. We're going to put it into a program, and it'll give us the height of the tree. It was also 50 degrees. So I'm at the 20 meter mark, and this is down the hill a little bit, and you can see in my quadrat that there's only very few plants in it. I've got a new plant type that I haven't had before, so I'll mark that down as plant 5, and then I have a few of the little bits of grass I had before. Down here I can do a total count on that for my biodiversity, so I can do my Simpson's diversity index. The rest of it, there's only a couple of plants, so I'll count that, and I keep collecting data down here. This is the 20 meter mark. So what I've been doing is collecting and adding to my EpiCollect at each point. It takes a little bit of time. Make sure you have 2 people with you, and you also have someone giving you a hand as you go, who's happy to give you a hand.
So here are some takeaways that I took away from doing this. 1, have all your equipment sorted out before you go. Have a plan, know what you're going to collect. So when I got out there on the field site, I just selected an area that's absolutely suited what I was looking for. I had to know that my issue for the project was vegetation loss due to urban planning or urban development, which was due to a population increase in Townsville. I'd already done all that data research, including some secondary research. I knew that the area that was grassed, actually even the area that was cleared, was still freehold land, but is going to be converted into the land tenure for urban development. With that, I did that quadrant analysis. You could do it all 9 points. That's what you need to do. You need to take some time with it, get it collected. The good data you collect at the start of a field report, the better you can then transform that. You can then transform the geolocate the points. I would suggest again using Google Maps of some sort to pinpoint that exactly every 5 meters, because the EpiCollect is not quite perfect on your phone. You do need a good GPS system, which a normal GPS without a ground source that gives it a fourth data point, which is past really what's in this course, but it won't be accurate enough. Then you've got enough data to take back to your computer and start transforming it, and then dealing with the guts of the report, which is really dealing with what is happening as a response to the challenge and what are your proposals. But you do have to show that there is a challenge, and that's the point of the field research. In my case, it shows there's a very clear transition between the area that's not clean, that is native forest up the hill, and then the area that has been cleared. Very clear delineation of the loss of species, biodiversity. There'd be less wildlife, even though I did see a kangaroo. That was only just one eating on the grass. The area has also got erosion issues, and of course, in general, we've got some probably a lack of infiltration because of the root system not aerating the soil, and then there's going to be more runoff, and then of course more erosion as a result. So it all sort of ties together. I hope that has helped you out. I hope that this example will then let you do a good job at your site, wherever you happen to be. And remember, the data is only just the first part to really show that there is an issue and a challenge at your site that has to be sorted out. And you need to get that before you go, because you're really only collecting this data to give you a representative example of the problem that's going on that needs some form of, or it's a challenge that needs to be managed.